Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-1 Extra Practice Solutions on polar coordinates. On this problem, we're trying to graph these two polar coordinates on this polar axis here. So for point A, the tricky part about this is you have a negative radius. So one way to handle that, you can think about this as walking backwards, looking in the 45-degree direction. So you could look this way, but walk backwards 4 steps. Another way to think about it is you could turn around and walk forwards 4 steps. So mathematically, that would mean making your radius a positive 4 and adding 180, doing a 180 with your angle. So we could think of this really as the point 4, 225. So we're starting here, looking in the 225 direction and walking 1, 2, 3, 4 steps out to get point A. All right, now on to point B, 2, 630. Well, this isn't even on the polar axes because this is bigger than 360. So the key here is just subtract 360 until you get a number that is between 0 and 360 degrees. 630 minus 360, that's going to be 270. So this is 2, 270. So we're just looking in the 270 direction and taking 2 steps out to get point B. For this problem, we're trying to get 2 other pairs of polar coordinates to represent this point. So there's 2 big moves that you can do on here. You can keep the radius the way it is and either add or subtract 360 as many times as you want. So for example, we could call this -1, whatever 240 plus 360 is. So 1, 600 degrees. Another thing you can do is you can change the radius, the sign of the radius, and either add or subtract 180 to the angle. So we could call this 1, and then we could do 240 plus 180 or minus 180, either way. So this would be 1, 420 in this case. But you also could have done 1, 60 degrees, either way. To turn these rectangular coordinates into a polar point, we need to get a radius and an angle out of these. Let's start with the radius. That's just going to be the square root of x squared plus y squared, basically a Pythagorean theorem on these things. So we've got -3 squared and 3 radical 3 over 2 squared. And let's just square these individually. So this is going to be, let's see here, 9 over 4 if we square this. This one over here, let's see, this is going to be 9 times 3, so that's 27. And we have a 4 downstairs, so 27 over 4. So we have 9/4 plus 27/4. That's going to come out to 36 over 4, which is just 9 when all the dust settles there. Square root of 9 gives us a radius of exactly 3. So now we get our angle. That's going to be inverse tan of y over x. So let's do inverse tan of, let's see, 3 radical 3 over 2 over -3 over 2. And you can cancel a little bit if you want before you actually plug this in your calculator if this is going to be messy to plug in. So the 3's here can cancel. The 2 denominators can cancel. You're really just doing negative radical 3 over 1 or negative radical 3. So let's do that on the calculator. So here we go. Tan inverse of -√3. Comes out to -60, but we always have to double check with these to make sure that the angle our calculator gives us actually matches the same quadrant as the point that they gave us. So the point that we have up here, negative x value, positive y value, that's over in quadrant 2. This point down here, -60 degrees, that's in quadrant 4. That's a mismatch. So to get the correct quadrant, we have to add 180 to this angle, so that'll be -60 plus 180 is 120, and that gives us the quadrant 2 equivalent of this angle right here. So putting it all together then, we're going to have the polar point 3, 120 degrees. To turn this into a polar point, we need to get an r and a theta value. For the radius, we use Pythagorean theorem on the x and the y value here. So square root of x squared plus y squared. That's going to be 1 squared plus √3 squared. So that's just 1 plus 3, which is 4, but we're square rooting that. So that actually ends up giving us 2. And now for the theta, we know that tan of theta equals y over x. So we're basically doing inverse tan of -√3 over 1, or just negative root 3. So let's do that on the calculator. So here we go. Tan inverse of negative root 3 comes out to negative 60. But let's just check to make sure that matches the quadrant of the point they gave us. 1 comma negative root 3, positive x, negative y, we're down in quadrant 4. Negative 60 degrees is also in quadrant 4. So these things match and we don't have to add 180. Putting it together then to get the total point, that's going to be 2 comma negative 60 degrees. To get polar coordinates for this point, we need to find the radius and the theta. For radius, let's use Pythagorean theorem, square root of x squared plus y squared. So that's this thing squared plus this thing squared. Now, these are essentially the same thing, only one's negative and one's positive, but they're going to give you the same thing when you square this. So let's see what we end up getting. This is going to be, let's see, 9 times 2, which is 18, all over 4. So this is going to be 18 fourths plus another 18 fourths. That's a grand total of 36 over 4, which actually just reduces to 9 when all is said and done. Square root of 9 is 3, so that's our radius. And now to get the theta, we know tan of theta equals y over x. So theta is going to be inverse tan of the y value over the x value. Now, it turns out, if you were paying attention here, that these are actually the same exact number, but negative versus positive. So this is really doing tan inverse of negative 1. And you might just happen to remember that that's going to be negative 45, but you could certainly find that on the calculator if you wanted to. Let's check to make sure this matches the point that they gave us up here. The rectangular point with the negative x value and the positive y value, that's up in quadrant 2. Negative 45 is down in quadrant 4. Since our quadrants don't match, we have to make sure our angle matches the quadrant of the point that they gave us. So we can do that by just adding 180 to our quadrant 4 answer here. That'll give us the kitty corner quadrant, quadrant 2. So negative 45 plus 180 gives us 135 degrees, giving us a final polar coordinate of 3 comma 135 degrees. To get polar coordinates for this point, let's find the r and the theta. For r, we're going to do square root of x squared plus y squared. So that's basically Pythagorean theorem. We've got negative 2 squared plus 2 radical 3 squared. That's going to be 4 plus, let's see, this is 4 times 3, so 12. 4 plus 12 is going to give us 16 inside the square root. So that ends up giving us 4 for the radius. Next, for the theta, we know tan of theta is going to be y over x. So that means inverse tan, we're going to have 2 radical 3 over negative 2, which is basically just inverse tan of a negative radical 3. If you do that on the calculator, and I've seen it several other times on this extra practice, but if you do that on the calculator, it comes out to negative 60 degrees. Let's just check to see if the quadrants match here. So we've got negative x, positive y, that's quadrant 2 for the rectangular point. Negative 60 degrees is down in quadrant 4. We need to make this angle match this quadrant up here, so we can do that by adding 180 to negative 60. That'll give us the quadrant 2 angle of 120. And so our final polar coordinate then, that tells us where we actually are in terms of this rectangular point, we're going to have 4 comma 120. On this problem, we want rectangular coordinates for this point. So to get the x value, so we have an r and a theta, to get the x value, that's going to be r times the cosine of theta. So that's going to be 2 times cosine of 0. Cosine of 0 is 1, so that's just going to be 2 times 1, or 2. So we have 2 comma something for our rectangular point. Next, to get the y value, that's going to be r times the sine of theta. So that's going to be 2 sine of 0. Sine of 0 degrees is 0, so that zeroes everything out here. So then we end up with a y value down here of 0. So then 2 comma 0 is our rectangular point. On this problem, we want rectangular coordinates for this polar point. To get the x value, given an r and a theta, we have to do r times the cosine of theta. So in this case, that's going to be 1 times cosine of 60 degrees. Cosine of 60, you might remember, is 1/2. So this is 1 times 1/2, or simply 1/2. So that's going to be our x value. For the y value, that's going to be r times the sine of theta, which in this case is 1 times sine of 60 degrees. Sine of 60 is radical 3 over 2, So 1 times that gives us root 3 over 2 for the y value. For this problem, we're trying to convert 2, 315 degrees into a rectangular point. So to do this, given an r and a theta, to get the x value, we need to do r times the cosine of the theta. So in this case, that's 2 times cosine of 315. We're going to have to use a little reference angle magic to make this happen. Cosine of 315, well, let's get a reference angle. 315 is 45 degrees away from the x-axis, so that's our reference angle. And 315 is in quadrant 4, where cosine, the x value of the angle, is positive. So we can rewrite all of this as 2 times the positive cosine of 45 degrees. And cosine of 45 is root 2 over 2. So we have 2 times that. These 2's are going to cancel, leaving us with just radical 2 for the x value. Okay, so let's get the y value now. That's going to be r times the sine of theta. So 2 times sine of 315. Still have a reference angle of 45, but now sine is the y values, and down in quadrant 4, below the x-axis, y values are negative. So this is going to be negative 2 times the sine of 45 degrees. Sine of 45 is also radical 2 over 2. So if we cancel out these 2's, we end up with negative radical 2 for the y value. For this problem, we want to convert the polar coordinate 2, 135 into a rectangular coordinate. So we need an x and a y out of this. For x, we need r times the cosine of theta. That's 2 times cosine of 135 degrees. And we're going to use some reference angles and a little bit of trig magic here. So 135 has a reference angle of 45 degrees because we're 45 degrees away from the closest x-axis angle of 180. Cosine is the x value of the angle. That's going to be negative at 135 degrees because you're to the left of the y-axis. So we can rewrite this as negative 2 times the cosine of 45. Cosine of 45 is root 2 over 2. Canceling out these 2's, we end up with an x value of negative radical 2. Now for the y value, which is r times the sine of theta. That's 2 times sine of 135. Same reference angle, 45 degrees. Sine is positive at 135 because we are above the x-axis, and sine represents the y value of the angle. So this is going to be 2, positive 2, times the sine of 45 degrees. Sine of 45 is also root 2 over 2. So these 2's cancel. We have positive root 2 then for the y value.